Hey, and good day to you all, and we're back to it with a little bit more algebra today. We're closing in on the end of our unit here on quadratics. The good news about today, once again, not really any new mechanics to teach you, just more focus on how do we use what we already know to move between forms. So how do we go from standard form to vertex form? How do we go from vertex form to standard form? So once again, the good news is you've been taught everything that you need to know today. It's just about taking those things that you know, putting them all together, and moving in between forms fluently. All right, so speaking of those forms, if you look at our warm-up here, our opener here, all right, we have two graphing problems. The first one is in standard form. The second one is in vertex form. And so what I would like you to do right now is graph those two quadratics and then tell me what do you notice about those two graphs. And then once again, you can either turn the video back on to check your work, all right, or you can have your fully worked notes open and compare your work with those. All right, so once again, I have the work for our opener worked here, so I'm going to flip over to that so we can see my work. So when we look at the first one, once again, anytime it's in standard form, we have to do a little bit of work to find the vertex. And so we have to use that little formula, negative b over 2a, to find the x coordinate of our vertex. All right, and so when we look at our quadratic here, a is 1, b is negative 4, and c is positive 7. So when I do the opposite of b, that becomes a positive 4, and then 2 times 1. So we get 4 divided by 2, which is 2. Then we just have to take that 2 and plug it back into our original equation to find the corresponding y value. So what we see is our vertex is 2, 3. So that's the point I have right here. And then our a value is 1. So I go up 1 to the right one, up 1 to the left one. And then we want to do 3a, which would be 3 this time, up 3 to the right one, up 3 to the left one. And so we can see that here is the graph of this quadratic right here. Now, we move to number 2. Number 2 is a little less work because it's in vertex form for us. So we can see the vertex for this graph is 2, 3. All right, so start with that point, 2, 3. Our a value is 1 right here. All right, remember we said that if there's no number in front, we assume it's a 1. If we saw just a negative here, that would be a negative 1. So a is 1, so up 1 to the right one, up 1 to the left one, and then we do 3a to get our next set of points. So from this point, up 3 to the right one, up 3 to the left one, and there's our graph. And what do you notice? Hopefully, if you did things correctly, these are the exact same graphs. And so what that means is these are equivalent forms. So the question is, how do I take the first one, all right, y equals x squared minus 4x plus 7, and make it look like the second one, y equals, all right, the quantity x minus 2 squared plus 3, or vice versa? How do I go from the vertex form to the standard form? And that, my friends, is the conversation for today. So let's go back and to that first sheet of notes here. Let me flip back here, all right, and let's go down. And we're going to actually work on going from vertex form, all right, to standard form first. So the first thing that we're going to do is we're going to use our area model, all right. So we did this way back real early in this unit when we multiplied, all right, polynomials, and we were doing a binomial times a binomial. So we're going to use that area model to expand whatever is squared, whatever is raised to that power. Then we're going to multiply by our a value, and then we'll combine like terms. So that's really the process that we want to use, all right, as we go through this. So let me pick a pen here. Let's start with green today, all right, and let's go through this. Now, so remember this, and we talked a little about this a few weeks ago when we did this lesson, but x plus 3 squared is really x plus 3, all right, times x plus 3, all right? And then we still have this minus 6 out here. Now, it's really following order of operations. And we know from order of operations we have to take care of multiplication before we do any of the subtraction. So we need to multiply these two guys before we can do any subtraction of the 6 out here. So once again, go into our area model. This would be our x. This is our positive 3 here. This is the x. This is positive 3 here. All right, and so x times x is x squared. X times 3 is a positive 3x. And then 3 times x is a positive 3x here. And then 3 times 3 is a positive 9 right here. There we go. All right, now what we know is if I look at this, I can combine like terms. Now notice my a value here is a 1. So what that really means is I don't have to worry about step number 2, because if I take this 1 and multiply it into everything, it's not going to change. So when I combine my like terms for my area model, I can just bring them over here. So this would be x squared. And then 3x plus 3x is 6x. And then this plus 9 would be the plus 9 right here. And then I'm going to bring down the negative 6 here. All right, so that brings us to step 3 here, which is combine like terms. So if I look, the only like terms are my numbers here at the end. So those are the only two that I can combine. All right, so y equals x squared plus 6x. And then 9 minus 6 is a positive 3. And there we have now taken this from vertex form to standard form. So if we were to graph both of these, we would get the exact same picture. All right, so let's move on to number 2 here. Now notice in number 2, we do have something other than a equals 1. We have this negative out here, so that is negative 1. So I'm going to write this as y equals. I'm going to just write negative 1 to emphasize that. And then x minus 4 squared is x minus 4 times x minus 4, and then that's plus 5. All right, so once again, I'm just going to take our two binomials. I'm going to come right over to my area model here. So x minus 4 and x minus 4. Now, I had these drawn in myself. So one of the things that you have to realize is that you have to recognize that, oh, I have x minus 4 times x minus 4. So you may have to sketch your area model to do that. I just put that in a little ahead of time because I'm never sure exactly how well I can draw. All right, so I wanted to save a little bit of time. But x times x is x squared. All right, x times negative 4 is negative 4x. Negative 4 times x is negative 4x. And then negative 4 times negative 4 is a positive 16. Now this time, I'm going to leave this a value out here. So I'm going to, as I combine like terms from my area model, all right, I'm going to leave the negative 1 out here, but I'm going to open a set of parentheses to put our result in here. So I'm going to combine everything here and put it in parentheses so that when I distribute this, I can make sure I distribute it to everything. So then we're going to have x squared. And then negative 4x and negative 4x is a negative 8x. And then we have our positive 16. And then I'm going to bring down this plus 5 on the outside. Now, once again, we're still following order of operations here. So we really had three things to multiply here, okay? So we had the negative 1, the x minus 4, the x minus 4. Well, we did x minus 4 times x minus 4 first, which is this result. So once again, we have to finish our multiplication before we can get to the addition over here. So I have to distribute that negative 1 to all three terms inside of our parentheses. So negative 1 times x squared would be negative x squared. Negative 1 times negative 8 would be a positive 8x. And then negative 1 times 16 would be a negative 16. And then once again, we had to bring that plus 5 down on the outside. And now we find ourselves back in the same step, all right, same situation over here for that final step is that we want to combine like terms, and our only like terms are those two constants at the end. So negative x squared plus 8x, and then negative 16 plus 5 would be negative 11. And that would be the equivalent version to this guy. All right, so now I think it's time for you to jump in and do a couple on your own. So if you want to flip to the next pages of the notes, all right, we have 3 and 4 here. So what I'd like you to do is go ahead and attempt those two problems on your own. And then once again, either flip the video back on to check your work, or have the fully worked note sheet open online or print it out, or however you want to look at it to check your work. But work it, check it, and I'll see how you did in just a moment. All right, so once again, I have the work here on the side, so I'm going to just flip to this. All right, wrong sheet. Let me flip up here. There we go. That's the one we want. So once again, leave that a value on the outside. X minus 4 squared is x minus 4 times x minus 4. So you can see I brought that over to our area model. X times x is x squared. X times negative 4 is negative 4x. Negative 4 times x is negative 4x. Negative 4 times negative 4 is a positive 16. And so leave that a value outside as we combine like terms. So x squared, and then negative 4x, and negative 4x is negative 8x, and then plus 16. Now we distribute the 2 to all three terms. So 2 times x squared is 2x squared. 2 times negative 8 is negative 16x. 2 times 16 is 32. And then once again, these are our only like terms out here. So 32 plus 5 is 37. All right, in a very similar fashion over here, we're going to leave that a value, which is negative 4. We're going to put that out front. X plus 6 squared is x plus 6 times x plus 6. So we see that in our area model. X times x is x squared. X times 6 is 6x. 6 times x is 6x. 6 times 6 is 36. Whew. All right, and now, once again, leaving the a value out, take our area model and combine like terms. We get x squared plus 12x plus 36. Now distribute that negative 4 to everything inside of our parentheses here. So negative 4x minus 48x minus 144, and then we bring down that negative 12. And then once again, these are the only two guys we can combine. So we bring these two terms down. Negative 144 minus that 12 is negative 156. All right, so that is how we go from vertex form to standard form. So now let's flip back to this page of notes and let's talk about how we go from standard form to vertex form. Now, there is another way to do this. It's called completing the square. We're not going to do that at this time. All right, we'll get to that in Algebra 2. All right, so what we're going to work on is using the tools that we already know how to do. So if I can get my stop moving, stop. Thank you. All right, so now we know that vertex form looks like this. So we really have to have three pieces, all right, in order to do that. We have to know our a value. Well, we know how to find the a value in standard form. It's always the coefficient in front of our x squared term. So that's not really the hard part. But we also have to find the x coordinate of the vertex and the y coordinate of the vertex. So here's what I mean by using the tools that we already know. Well, we know how to find the x coordinate of the vertex when it's in standard form. We use our little formula, negative b over 2a. And we know how to find the y value by taking that value and plugging it back in, all right, to solve for that y value. So that's what we're going to do. We're going to identify a, plug it in. We're going to use this to find our x value, which is really the h value, and then we'll plug it back in to get our k value. All right, so working with this guy, I'm going to go through the first one here with you. All right, so when we look at what we have right here, all right, we know that a is 1. We know b is 8. All right, and we know c is 12. So we can identify those values just like we have been. And then what we're looking for here, right, is we know y equals a times x minus h quantity squared plus k. And so notice right now we already have the a value. We know a is 1. So I'm just going to go right here and I'm just going to slide that guy in right there. So it's 1 right there. So now let's go to step 2. We're going to find our x coordinate using negative b over 2a. So x equals, all right, now the opposite of b is positive, so that's going to become a negative 8 over 2 times a, so 2 times 1. All right, that's going to give us negative 8 divided by 2, which is equal to negative 4. So there's our h value. So I'm going to plug that in right here. Now notice this is minus h. So if we put in a negative h value, that is going to make that a positive. So x, and then that's going to become a plus 4, and then squared like that. So the only thing we're missing is this k value. And so remember the way we do that is we take whatever x value we get here and we go back and we plug it back in. So y equals, all right, and so I have negative 4 squared plus 8 times negative 4 and then plus 12. And this is where we can use our calculator. So I'm going to come over here to my calculator. All right, let me clear out my old screen here. All right, you can see still got some of the work from one of our prior lessons there. And then once again, I'm going to type just what I wrote, parentheses included, All right. So if you write it well, if you get into a good habit of using your parentheses, all right, those kind of things, it really makes then using your calculator much easier. All right, so I type all that in and we get a y value of negative 16. All right, so did I type all that in correctly? Let me see, did I do all that? All right. Okay. Oh, I did not type it in correctly. All right, I typed the first line. I was going to say, it seems it's different than what I remembered getting in my notes. All right, so I did negative 4 and then squared. All right, so that's what I did wrong. Plus 8 and then negative 4. I think I typed a 2 in that first time by accident. I was like, it did not match what I had in my notes. So we should get negative 4. So then our y value here is negative 4. All right, and so that means I can come up and just fill that guy in right here. All right, so let's do one more together. All right, so let's look at number 2 together, and I'm just going to start by identifying all my values here. So we'll start with our a value. All right, so a is negative 1, b is 6, and c is negative 9. And then once again, we know what vertex form looks like. So y equals a, and then x minus h squared plus k. And we already have part of the puzzle because we know a is negative 1. So I'm just going to go ahead and write that in. So negative 1. And then I'll start our parenthesis for the next part. So now let's start by finding our vertex. All right, so x equals, all right, the opposite of b. So b is positive 6, so now that's going to become a negative 6. All right, over 2 times a. So we get negative 6 in the numerator divided by negative 2, and that gets us to a positive 3. So there's the next piece of our puzzle. All right, so we know h is 3, so I'm going to have x minus 3 quantity squared. So lastly, we had to find our k value. So y equals, all right, and then we have that negative 1 out front, and then we are going to have 3 squared plus 6 times 3, and then minus 9. All right, and I'm going to go to my calculator here. So negative 1, 3 squared plus 6 times 3 minus 9. And that should equal to, oh, got 0. All right, so our y value here this time, all right, is 0. All right, and no big deal, right? We know that we can have a vertex that sits on the x-axis, which is what's happening here. So our vertex is also our x-intercept. Now you can write the plus 0 out here, or you can just leave it like we had it here. All right, so once again, I want you to finish the lesson for today by doing problems 3 and 4 on your own. And then once again, either check that with the fully worked notes that are online, all right, or you can pop the video back on and we'll work through it together. All right, so let's take a look at 3 and 4. All right, so here's the work for both of those. So if you look at number 3, a is negative 3, b is 12, and c is negative 1. All right, so you can see that when we do our negative b over 2a, we're going to get negative 12 over 2 times negative 3. That gives us negative 12 divided by negative 6, which is a positive 2. And we go back and plug 2 back into our equation here, like I did here, and you get y equals 11. So if we take our a value, our h, and our k and plug it in, you should get the equation y equals negative 3 times the quantity x minus 2 squared plus 11. All right. Now, moving on to number 4. All right, very similar process. A is 2, b is negative 16, c is 5. All right, so when I do the opposite of b, this becomes a positive, and then I have 2 times 2 in the denominator. 16 divided by 4 is 4. All right, and then we just got to take that 4 and go back and plug it back in. All right, so 2 times 4 squared minus 16 times 4 plus 5. All right, so, and you should get negative 27. If I take our a value, our k value, and, or excuse me, our h value and our k value, plug it in. There is your equivalent form. All right, so that wraps up our lesson on equivalent forms. That leaves us just one final lesson for quadratics, which is applications, and we will get to that next. So once again, work through the homework. All right, email us if you have questions. Come hang out with us. All right, look for those links on our website, on Schoology, wherever they may be. All right, let us know if you have questions. We'd love to see you. All right, hopefully you're taking care of yourselves, having a good time, enjoying some of the sunlight that's out. It's nice and warm today. All right, take care of yourself, take care of each other, and we will see you soon, my friends.